Hey everyone, happy February break. Whether it is Friday night or Tuesday night, whichever time you are watching this, I hope your break has gone well so far. Our title is Completing the Square to Find Zeros, and what we're going to do for our opener is sketch a picture of the completed square given these expressions: x squared plus 16x plus 68 and x squared minus 6x plus 12. So I included a little picture of the algebra tiles right here. So if you forgot, we're going to use these tiles to help us complete the square. Take a moment and do that. We're sketching a picture with the tiles. And after you're done getting an answer, go ahead and press play on the video and see if you got your answers right. So our first one, we have 1x squared. So that's our x squared value right here. We have 16 x's, so we know we want to break those up evenly if you're thinking about our equation, half of b squared. So we're going to break those up evenly into 8 x's. I think that's 8. 1, 2, 3, yep. And 8 x's. 4, 5, 6, 7, 8. Now, we could start laying out dots individually, but we know we can find a faster way to figure out how many would go here. 8 by 8 we know is 64, so there are 64 unit cubes here. However, we have 4 extra unit cubes because we have 68. So that would be our picture that we have right there. If you want to go the extra mile, even if though it said it didn't ask you to do so, what we can do is we can write our equation in vertex form. So we would have f of x equals our side length, which is x plus 8 squared, plus 4. Those 4 represent those 4 left over. We also know our vertex would be negative 8, 4 in this equation. The second one, we've got 1x squared. We've got negative 6x. So again, I know we don't have red blocks, but we can still incorporate the negative sign in our final answer. Here are our 3 and 3 x's, which makes the negative 6x. We've got 12 units. So when we fill that in, we only need 9. We have 1, 2, 3 extra. So again, our equation would be f of x equals x minus 3. And remember, it's x minus 3 because we have this negative sign right there. X minus 3 plus 3. Our vertex is 3, 3. If you were to go on Desmos and graph that, that would be the vertex right there. All right. Just a reminder that this is lesson 1, so this would be the first lesson, first video you would be watching. So what we just did is completing the square visual, and our mini lesson is going to be completing the square to solve an equation practice. So this is the 5th period video. The reason why you have a different video 5th period is because we didn't complete the graphic organizer on Friday because we had a different discussion. So we're going to do that in this video today. You won't have more work than the other classes. You'll just have a little bit different notes page than everybody else. Remember, we do not have a work session that involves this unit. The only thing that you're turning in on Wednesday is your page of notes that you take from this video. So let's start by completing that graphic organizer, and that'll be our lesson for the day that you're going to watch. You should have this in your notebook because I asked you to put it in your notebook. I think I asked you to tape it or glue it or something like that into your class notes section. But if for some reason you don't have it, you can just write these down on paper, the 2 columns, and then I'll give you the paper on Wednesday so you can have the step-by-step instructions too. So completing the square is great to write things in vertex form, but you can also use completing the square to find your zeros, which is great because if we are so good at completing the square, then if we can use it to find our zeros on complicated equations, then that's a good thing. So let's start doing that. The first example that we're going to start with is x squared plus 2x minus 24 equals 0. So again, we're kind of marrying the idea of completing the square and then taking it a step further, marrying that with finding the zeros of an equation. So our first one, step 1, move the number term to one side of the equation and keep your x squared and x terms on the other. So if we take our original equation and move the number term to the other side, that would be the number term right there. The inverse of subtraction is addition, so we're going to add the 24s to each side. We get x squared plus 2x equals 0. And this is great because we know that this part of the equation we can complete the square on. Step 2, make sure that the coefficient on your x squared term is a 1. So if I look, the coefficient on my x squared term is a 1. So for this box, I'm just going to put yes, a equals 1. Just a little strategy for yourself to recognize, okay, I know I can complete the square because I have an a value of 1. Step 3, find the number that will complete the square for the x squared and x terms. Perfect. We've done this a ton already. So we're looking for the number. If we had 1x squared, 2x's, what would we have to add to the equation in order to get our, in order to complete the square? So I'm going to do this visually, and I'll do this with our equation too. So there's our x squared term. If I break my two x's up, I would have 1 and 1, and I have one individual unit cube that I'm adding to it. So I've got the 1 there. If I do this with the equation, I cut my 2 in half, which is the same thing I did visually. 2 divided by 2 is 1. And in order to figure out how many square units I need to add, I just do 1 squared, which is 1. So again, equation, visual. Next, step 4. Add the number from step 3, which was a 1, to both sides of the equation. So the reason why we're doing this is because if you remember when you first learned about equations, your teacher probably described them as a balance, like a scale. If you add something to one side of the scale, you need to add it to the other side in order to keep the equation balanced. So if we added a 1 to one side of the equation, we need to add a 1 to the other side as well. Step 5, factor the trinomial, simplify. We've done this a bunch of times as well. So if we were to rewrite this quantity in vertex form, that would look like x plus 1 squared. And just remember, all that is the side length of the square. Make a little note, side length of the square. All right. Equals, simplify the other side, 24 plus 1 is 25. Now, we're on to finding the zeros, and it's easier than you think. Step 6, take the square root of both sides in order to cancel out the squared term. This breaks the equation into two separate parts. So let's just write the same equation twice, and I'll explain the two separate parts thing. So we have x plus 1 squared equals 25, and x plus 1 squared equals 25. So way back in 8th grade, way back, 1 year ago, square root of 25, they said was 5, because you knew 5 times 5 made 25. But there's another square root of 25. It's negative 5. So the square root of 25 could be 5 or negative 5. Let's look. 5 times 5 is 25. Negative 5 times negative 5. Y'all know a negative times a negative makes positive. That's also 25. So whenever we take the square root of a number, we have to recognize, wait a minute, it could be 5 or negative 5. That's where our two zeros come from. So let's do that. Let's take the square root of both sides of the equation. We'll do that on both of them kind of simultaneously. So we have x plus 1, because squaring and square rooting cancel, and the square root of 25 is 5. And on this side, again, the squaring and the square root and the squaring cancel, and we'll say this root equals negative 5. To figure out what your zero is, subtract 1 on both sides. This is x equals 4, and on this one again, subtract 1 on both sides, x equals negative 6. So we are done. We found our two zeros. Check your solutions. All that means is in x plus 1 squared equals 25, if we plug in a 4, will we still have a true statement? 4 plus 1 is 5. 5 squared is 25. We do have a true statement. Check it with the other one. If you plug in a negative 6, what's negative 6 plus 1? Negative 5. Negative 5 squared is 25. We know we have the right answer. You literally can do this on any test and be 100% sure you have the right answer, which is pretty cool. Let's try our second example. So you've got a few more. Let's try our second one. This one's just a little more complicated, but absolutely nothing we can't handle. So what that one is, we've got 2x squared minus 20x minus 22 equals 0. Again, we're completing the square to find our zeros. So step 1, again, move the number term to one side. So we've got 2x squared minus 20x minus 22 equals 0. We're going to add 22 to both sides to give us 2x squared minus 20x equals 22. Make sure for step 2 that your a value is equal to 1. It's not. It's a 2. So what do we normally do? We factor the greatest common factor out. And it's even easier with equations because all we have to do is divide everything by 2, because if we do, we will still have the same equation. And by same, I mean we'll still have an equation that is equivalent to what we just had. So 2x squared divided by 2 is x squared minus 10x, 20 divided by 2, equals 11. We jump right back to where we were. Step 3, complete the square. X squared minus 10x plus what value do we need to add? Again, we'll show you with algebra tiles and with the formula. I'll do the formula first. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So I know I'm going to have 25 units. But let's check with the picture. Here's my x squared. I break up negative 10 into 5 and 5. I know in this box right here, I'm going to have 25 unit cubes. Step 4, add the number from step 3 to both sides of the equation. All right, x squared minus 10x plus 25. On the other side, I've got 11 plus 25. So we added that 25 to both sides. Simplify the expression. So again, this perfect square trinomial is going to become some binomial squared. We know it'd be x minus 5. Again, it's minus 5 because we have a negative 10 right there. Equals 11 plus 25 is 36. And again, just remember, this is a side length. That's the side length of the square. Don't try and make that harder than it needs to be. Now we've got x minus 5. We're going to solve for our zeros. Squared equals 36. X minus 5 squared equals 36. I don't know why my writing is looking all sloppy, but it's all right. We're going to solve. I'm going to have to keep moving quickly because my 15 minutes is almost up. We are taking the square root of both sides. So we would have x minus 5 equals 6, and x minus 5 equals negative 6, because remember, those are the two roots. Add 5 to both sides. That would give us 11, and on this side it would give us negative 1. Checking our answers, because we found our zeros. Checking our answers. X minus 5 squared equals 36. I plug in an 11. 11 minus 5 is 6. 6 squared is 36. Excellent. Other one, I plug in a negative 1. Negative 1 minus 5 is negative 6. Negative 6 squared is 36. We know we've done it right. We know we've checked it. If you were to graph either one of those equations, this one or this one, you would notice that your x-intercepts of that equation would be those points for this equation and these points for that equation. Go on Desmos. Try it. It works. When you come back to class on Monday, or not on Monday, on Wednesday, you're going to get some more practice with this. We'll practice the drawing. Y'all will do great. Go back, review the notes, make some questions or make some comments if you're not understanding a certain step. Be prepared tomorrow when you come into class. It's a great way to, again, making those comments and writing side notes to yourself about questions or your own kind of thoughts about the process is a great way to learn and kind of reinforce what's going on. I will see y'all tomorrow.